Welcome to this week 7 problem 6, and the problem states that a biotech firm has done some research. They found that 16% of the sample of 1055 adults are okay with attempts to clone, and we want to make some calculations and an analysis from that. The first one is we're asked to find the margin of error for this code if we want 90% confidence in our estimate. Now, I'm going to be showing you the solution presented in MyStatLab, putting it right beside the Excel solution. And this Excel sheet is attached so you can look at it and analyze it to help you understand what the solution is. Now, this expression shows you the margin of error. It's the critical value times the square root of p hat times q hat over n. P hat and q hat are shown here, so let's go through and enter the data. Sample size was 1055. Percentage success was 16%. That calculates to a success count. It means 169 persons were okay with it. The confidence level that we need for the first one is 90%, so let's go ahead and make sure that's correct. And then this expression here is calculated manually for you to get to the margin of error. P hat is 0.16, which is given as the 16%. Q hat is going to be 1 minus P hat, which is in the expression here, and calculated as 0.84 in this cell for you. In the video for question number 3, we went into detail as to how to calculate the critical value, and the critical values are listed here for different levels of confidence. These are standard values, and you will, by using them, sort of learn what they are, but you still need to be able to produce these values here. So look back at that video if you're not very familiar with how we got to this. The standard error is this part of the expression. So that's p hat times q hat divided by n, which is what is calculated here, and then we have found the square root. And a quick side note is we want all of this to be raised to the power half, which is what a square root does. And we use this expression with the little caret which you get by using shift number 6. And I wanted to mention that because this is pretty powerful. If you wanted to square an expression, you could use this, raise it to the power 2. If you wanted to find the cube root of something, you would raise it to the power 1/3. If you wanted to find something raised to the power of 6, you could do the hat and number 6. So this is something that I think you all should know. So that was a little side note that I think was important. Now the margin of error is found by multiplying the z-score by the standard error, which is what we've done here, and we've included the ABS function, which essentially produces the size and ignores the sign. So if it's negative, it drops the negative sign. If it's positive, it just reports the value. So this gives you the size, the SIZE, and not the sign of the expression. So that's why we have the ABS. If you click on this cell and it distracts you, or you know what it is. So this is going to be our margin of error. Continuing on to part B, we're asked to explain what the margin of error means. Now the 16%, the sample that we chose gave us a value of 16%. And if we were to choose several samples and we did a plot for that, we would end up with a bell-shaped curve that looks like that. Now what the margin of error is, we are saying instead of reporting just the 16% as, hey, we're sure that that's the population proportion, but we're not sure because this was the proportion in the sample we found. To be able to extrapolate to the population, we then end up by widening this. So we find what the margin of error is and we widen this so that this area now becomes our confidence interval, right? So our confidence interval is now this area. So we move from the 16 up and down by our margin of error so that we now create a confidence interval. So this is what the results showed, and then this size represents what our margin of error is, so that we can say within this range from here to here, we are 90% sure that the true value will lie, or we can change it 90% by changing the size, and we'll go through that in a moment. But that's essentially what the margin of error is. It translates the result from one sample to the population to say, okay, we are this much sure that the population's proportion is going to lie within that range. Because the population proportion, as much as we select a statistically sound and scientific sample, it doesn't always mirror exactly the population. So this 16% is not always going to mirror what the population is. Now what we do with it, we say now we are 90% sure that the population value proportion lies between 14% and 17%, which is what these values are. Let's get these down. Right. Alright, so that's essentially what the margin of error is. It translates the actual success into a range that you can say you have a certain confidence that the true value lies within that range. Now moving on to part C, if we need to be 95% confident, will this margin of error be larger or smaller? Now if we just look at our graph here, which is quite messy, so I will do another one. If this represents a range that captures 90%, and we wanted to improve that to 95%, then the only way to be 95% sure is to go and capture a little bit more. So we would have to widen our range so that instead of just saying this area captures 90%, if we want to capture 95, then we have to widen that range to be able to be sure that we're capturing 90% of 95% of the data. So in essence, mathematically, what does that mean? How could you do this mathematically instead of just using logics? If you go from 90 to 95, your z-score increases from 1.64 to 1.96. So your margin of error, which is directly dependent on z, will increase. And again, if your margin of error increases, your confidence level, your upper limit and your lower limit, which is what these are. This is your confidence upper limit and this is your confidence lower limit. If your margin of error increases, then these values will also move away from each other, so the range will become larger than it was. Alright, so since 1.96 is larger than 1.64, the critical value for 95% is larger than for 90%. And if you think about it, if you want to be 95% sure, then you're going to widen your estimate so that you have more confidence in that. So it follows even with or without the maths calculation with it. So we want to find the margin of error for 95% using the same process we did in A. We can just change this here to 95%, and that's one of the beauties about using Excel. You can, if you change one input and you were reading from that, it automatically updates. So it spits out the 0.022 in a heartbeat using the same formula here. All of what this is doing is calculating this for you using Excel. Part E in general is all other aspects of the situation remain the same. Would a smaller sample produce a smaller or larger margin of error? If you were to zoom in on this expression, if we decreased the value of n, since it's in the denominator for this expression, you're dividing by a smaller value, it's going to give you a bigger result. And if that result is bigger, when you square root it, it's going to be bigger. So the margin of error is going to be bigger. So what's going to happen is it's also going to widen this range here. So the larger margin of error will mean that your sample, your critical confidence interval, I'm sorry, is going to be wider. Your margin of error is going to be larger simply because you decrease this. So in this case, it's 0.022. Let's just make a guess and decrease this by approximately a half. So let's take it to 525. And remember that this was 0.022. So if we decreased it, then we see that this margin of error went up. Alright, so whether you do it mathematically or you analyze the equation, you will see increase in n results in this expression being smaller, because dividing by a larger number gives you a smaller result. And then when you translate that, square root of a larger number is larger. Multiply that by z, which is constant, because you're saying that everything else remains the same. Then that translates to a larger margin of error. Alright, so if you have any questions, feel free to reach out to us. Alright, and thank you for watching.